You shouldn't use pen in math class. It is what it is. Okay. So let's go ahead and start. So this right here is solving a radical equation. You know, it's got a radical in it. So first step is to get the you want to isolate the radical. So the first thing I'm going to do is get rid of that 4. So I'm going to subtract 4 from both sides. So minus 4 on both sides. Because I want to isolate the radical. This thing right here. I want this thing to be all by itself on one side of the equation. Okay. So now I'm going to have 3 times x plus 12 under the square root equals 18. The next thing I'm going to do is get rid of that 3. So I'm going to divide both sides by 3 because this is 3 times the square root of x plus 12. So if I divide by 3 on both sides, then I just get the square root of x plus 12 on one side equals, and then 18 divided by 3 is 6. So see, I isolated the square root. Once I isolate the square root, I can get rid of it by taking both sides to the second power. Because remember, that's the opposite of square root. Every time we do something like this, we're doing the opposite of what's going on. We subtracted 4 when we wanted to get rid of the plus 4. We divided by 3 when we wanted to get rid of the 3 times. So in this case, when I got the square root on one side, I take both sides to the second power because that's the opposite of the square root. And so now those two things cancel. And I just wrote it anyway. So those two things cancel off, and now I just got x plus 12. But on this side, I got 6 to the second power. So that's 36. All right. So now it's just a regular equation. I just subtract 12 from both sides, and x equals 24. So now the check is I take that 24 and plug it back into the original expression that I got. So 3 times 24 plus 12, that's a 24, not a 29. Let's just erase that because that looks ugly. Okay. 24 plus 12 plus 4 equals 22. So 24 plus 12 is 36. So I got 3 with times 36 under the square root plus 4 equals 32. 22, sorry. 22. So the square root of 36 is 6. So that's 3 times 6 plus 4 equals 22. 3 times 6 is 18. So 18 plus 4 equals 22, and 22 equals 22. So that's the problem, solving the problem, and the check. So anybody got any questions? Yes, that's why the problem says solve and check. That's part of the problem. Yep. I'm moving forward for a second, just up a little bit. All right. So now we got simplifying radical expressions. Okay. So simplifying radical expressions, either I need to simplify my radicals or I need to eliminate my radicals. So in this problem right here, I need to simplify. So what I'm going to do is I'm going to break each radical down into 2 numbers. So 45 is what 2 numbers multiplied? 9 and 5. So I'm going to think of the square root of 9 times the square root of 5. And then when it comes to 125, that's the square root of 25 times the square root of 5. And then when I think of 20, that's the square root of 4 times the square root of 5. Can everybody see the pattern? All of them are multiples of 5, right? And they also have a perfect square, 9, 25, 4. So the reason I did it like that was so I can take the square root of 9, it's 3. I can't take the square root of 5, so 45, or the square root of 45 simplified, is 3 times the square root of 5. Okay, 125 is 25 times 5. So the square root of 125, the square root of 25 is 5. The square root of 5 I can't take. And then finally, I've got the square root of 20. That's the square root of 4 times the square root of 5. Well, 4 is a perfect square. I can take the square root of that. That's 2. And so now I just have an expression. Now, when you're dealing with radicals, adding and subtracting, they work just like variables. I'll just go over here and explain what I mean. When I got x plus y, I can't do anything. But when I got x plus 2x, I can do something. Because they both had the same variable, I can make that 3x. So everybody follow me? So when I'm looking at radicals and I've got, say, the square root of 5 plus the square root of 5, I can add that together to make 2 square root of 5. I treat it just like variables. But if you had something like the square root of 5 plus the square root of 7, you can't do anything with that because the radicals are different. Okay? So with this, all of my radicals are the same. So I treat them like variables and I can just combine. So 3 square root of 5 minus 5 square root of 5. That's going to be negative 2 square root of 5. Does anybody have any questions on where I got that from? I'll say it one more time for the cheap seats. That when you have radicals that you're adding or subtracting, the radicals need to be exactly the same or they don't work together. Okay? I'm not done yet. I'm almost done. So then I've got plus the 2 times the square root of 5. Well, if you look, they're opposites. Minus 2 times the square root of 5 plus 2 times the square root of 5. They cancel each other out. So my answer for this one is 0. Anybody need one of these? Raise your hand. Is everybody? Are we taking this tomorrow? No. I was gonna give you 2 days and then 2 days to 2 days to take the test. Although I'm hoping it's only gonna take Thursday. But we'll see. Yeah, give me a minute. I'm just giving everybody one. See if I raise your hand. I'm gonna need you to come up here. You to go. Okay, and then we can get back on track. There you go. All right. So let's erase this stuff and continue. Okay. So when you've got a rational expression that has square roots, or another way to say it is if you got a fraction that has square roots in the denominator, you got to do what's called rationalizing the denominator. I can't have square roots in my denominator. There's a rule by some old dude that before I was born decided, hey, you need one of these? Okay. It's called rationalizing the denominator. Rationalize the denominator. So what that means is I need to take the conjugate of the denominator and multiply it top and bottom. The conjugate is just whatever I see there, changing the sign. So the conjugate is going to be 6 plus the square root of 2. So I'm going to multiply this top and bottom on my fraction. So I'm going to have the square root of 5 times 6 plus the square root of 2 over 6 minus the square root of 2 times 6 plus the square root of 2. Now, does anybody see that there's a pattern in the denominator? It looks like something that we talk about all the time in here. Does anybody know? The difference of squares. It's not the difference of squares, but it looks like it. I've got the same stuff, but excuse me, but different signs. If I got the same numbers or the same terms with different signs, when I multiply it, you remember when you have two binomials and you multiply them, you usually get three terms, right? The outer, the inner, and the middle. But when you have the same stuff that you're multiplying but different signs, that middle term cancels off. So all you got to do is worry about the first term times the first term, the last term times the last term. So when I'm multiplying these two things, all I got to do is worry about 6 times 6 and negative square root of 2 times positive square root of 2. Does everybody follow what I'm saying? I mean, I can take a little trip to the side and explain it more if you need me to. Yes, no, explain, don't explain. I'm right here, bro. If I got A plus B times A minus B, right? If I got that, when I do FOIL, I get A times A, that's A squared. I get A times a negative B, that's negative AB. Then I get plus B times A, that's plus AB. And then I get plus B times a negative B, that's negative B squared. These two things are opposites. They cancel each other out. So all I'm left with is A squared minus B squared. That's why we call it the difference of squares, because we're subtracting. Answer to a subtraction problem is called a difference. And then I've got two things that are squared. Well, in this case right here, it's going to be 6 minus the square root of 2 times 6 plus the square root of 2. So I'm going to say 6 times 6, that's 36. And then I'm going to say 6 times the positive square root of 2. So that's going to be plus 6 times the square root of 2. And then I've got negative square root of 2 times 6. That's going to be minus 6 times the square root of 2. And then I've got negative square root of 2 times positive square root of 2. That's going to be a negative square root of 4. All right, so I'll take a little breath right there and say, does everybody follow me there? Like I said, this works like the difference of squares, all right? Because the terms are the same, but the signs are different. Yes, ma'am. Okay. Because the terms are the same, but the signs are different. When I multiply, that middle term gets canceled off. Okay? Does that help make it plainer? Just do your best, bro. All right. So then let's get rid of this so I can finish the problem. All right. So right here, because the negative square root of 2 times the square root of 2. Remember, when I got stuff that's under the square root and I multiply or divide it, they can interact. But if I have something that's outside the square root times something that is inside the square root, they can't interact. It acts like a variable. So like 2 times a is just 2a. I can't do anything with that. But the square root of 2 times the square root of 2 is the square root of 4. You know, that's like me and you, we're conversing in the same room. So then I can multiply those two numbers. But like this one, that's Crosby outside, and then that's you inside. Y'all can't interact. So then it's just 6 times the square root of 2. Right? So anyway, when I multiply this thing, the first thing I need to do is right here is distribute. So I'm going to have the square root of 5 times 6. That's just going to be 6 times the square root of 5. And then I'm going to have the square root of 5 times the square root of 2. Remember, those are both under the square root. So they can get multiplied. So 5 times 2 is what? 10. So that's the square root of 10. So that's the top. And then we just was talking about what the bottom is. So the bottom is going to be 36 minus the square root of 4. And what's the square root of 4? 2. So I got 36 minus 2. That's going to be 34. So this is my answer. That's my answer. Right, I'm erasing this, all right? So anybody got any questions on number 2, A or B? All right, what do we know about number 3? There should be something right off. Oh shoot, there's something missing. It should be 13. It should be 42, I believe. So that should be 42. All right. So what do we know about dividing fractions? Come on, y'all. We do got a factor, but there was something else I was looking. Say it again, sir. Keep change, flip. All right. But Akira's right that the first thing we need to do is factor. So I look at this first um, expression: x squared plus 13x plus 42. That's supposed to be plus 42 if it's not on your stuff. So plus 42. So I need to think of what two numbers do I multiply to give me 42, but then I add them to get 13. 6 and 7. So that's going to be x plus 6 times x plus 7. And then I've got x plus 7 on the bottom right there. And then I flip this. Oh, shoot, I was wrong. Dang it. I was wrong. Sorry. Yeah, that's why you don't use pen. That's supposed to be 24. Sorry. Yep, not 42. It's 24. Say it again. It says 22. Let me see your package. Because it should say I'm 22. Because that's supposed to be um 11 plus 2. So 2 times 11 is wow, 22, man. I need to go to sleep. It's 22. I need to go to sleep is what I need to do. Thank you. Thank you, Cameron. I need to I owe you a piece of candy. So anyway, it's 22. So what two numbers, oh my God, Ferg, do you multiply to get 22, but when you add them, you get 13? 11 and 2. Wow. That took a whole lot of stuff to get to that point. Sorry about that. And then we got x plus 7 on the bottom. And so now we need to do the same here. So what can we factor x squared minus 121 to? Hint, it's what we just talked about like 5 seconds ago. So that's x plus 11 times x minus 11. That's the difference of squares. Yep. It's just what we talked about. Remember, when you multiply two binomials, you're supposed to get three terms. It does not say plus 20. Yeah, man, don't be. I already messed up once. You don't got to toy with my emotions. So anyway, so the middle term cancels off because these numbers are the same, or these terms are the same. So that's the difference of squares. All right. So now I've got a x squared plus 11x plus 28. So what two numbers multiply to give me 28? But when I add those same two numbers, I get 11. 7 and 4. X plus 7 times x plus 4. Now that I got that all factored up, I can do my keep change flip. So my keep change flip says I take 11 or x plus 11 times x plus 2 over x plus 7. That's my keep. That doesn't change. Then my change, my division sign becomes a multiplication sign. And then finally, my flip, I flip these over. So this becomes x plus 7 times x plus 4 on the top and x plus 11 times x minus 11 on the bottom. And so now, bless you, I can do my cross canceling. I can take off the x plus 11 from the top and the bottom. I can take my x plus 7 and my x plus 7 off the top and the bottom. Okay. Now, when you take those away, remember they're being canceled for one. It's like I'm dividing them out. So I'm not turning them to zero. It's like I'm saying x plus 7 divided by x plus 7 is 1. So when I eliminate those, they become 1. So right here, that goes away. I got a 1 down here. I get a 1 right there, and I get a 1 right there. All right, so then finally, now I just multiply off what I got left. So I've got x plus 2 times x plus 4 over x minus 11. And that's good enough. I won't ask you to simplify that anymore or work that out. That is simple or simple enough. All right, x plus 2 times x plus 4 divided by x minus 11. So anybody got any questions on that? Okay. And then finally, factor this group of polynomials. When you see 4 terms, that should be a red flag that we need to factor by grouping. Okay? So that's what we're doing here. We're factoring by grouping. So I'm just going to group the first 2 terms together and the last 2 terms together. All right? So I've got 5p cubed minus 10p squared, and I've got 3p minus 6. So what do these first 2 terms have in common? Okay, they can both be divided by 5, and they both have a couple p's, If it's hard for you to see, I could say 5 times p times p times p. That's what 5p to the third power is. And then I've got 10, that's 2 times 5 times p times p. And then I look for what they have in common. They got the 5, they got 1, 2 p's. So I'm going to pull out a 5 and p squared and then see what's left. Well, the first term just has a p left. The second term has a minus 2 left. Now it's easier to see what I can pull out from the second one. Yep. So the second one, I've got 3p minus 6. What do they have in common? I can just pull out a 3. So that's going to be, I'm just going to say plus 3. And that's going to be p minus 2. When you're doing this, and the terms that you got inside the parentheses don't match, you did something wrong. They need to match. And so now to get your final answer, you just take the 2 outside terms and put them together. And then take the term that's inside the parentheses. And that's my answer. No, because think about it like this, Dorian, that this is just, I'm distributing, right? So like real quick, if I took 5p squared and distributed that to this, or better yet, let's think about it the other way. If I took p minus 2 and distributed it to 5p squared and to 3, I would get this. If I took this and distributed that. Does that make sense? Okay. So then I'm going to do the same thing here. I'm going to take 2t cubed minus 5t squared, and I'm going to take negative 18t plus 81. Something don't look right. That's not going to work. Yeah, so that 81 needs to not be 81. Let's see. Yeah, but that's, like I said, that's not going to work. That's 2 times 9. That's 9 times 9. I need 5 times 9. Yeah, that needs to be 45. Well, I'm about to see, because that shouldn't work. Okay, so let's work it out. So anyway, what do these 2 things have in common? 2 t's. This has 3 t's. This has 2. So we're going to pull out 2 t's, and we're left with 2t minus 5. Okay, so now I look for what these 2 have in common. Now, they should have 9 in common. But the thing is this. If I look at what's inside the parentheses, my first term is positive. So when I pull something out, my first term should be positive here. So I'm going to pull out a negative 9. If I pull out a negative, if I pull out a negative 9, I get negative 2t. And if I pull out, no, shoot, man, I'm really messing up. Yeah, thank you. Akira, all you piece of candy. So if I pull out a negative 9, I get a positive 2t. And if I pull out a negative 9 here, I get negative 5, which that makes those even. And I must have did this while I was intoxicated or something because this don't make any sense. Yeah, this should be 45, not 81. Yeah, I might have been messing with wacky tobacco when I made this review. Okay. Yeah, that's right. It should be 45. It shouldn't be 81. I don't know why I got 81. Yeah. So anyway, what I'm just explaining. The reason that I did this problem, I wanted you to see that sometimes you pull out a negative number because my I want my terms inside the parentheses to be exactly the same. So in order for that to happen, I needed to pull out a negative 9. All right. So then the final answer is t squared minus 9 times 2t minus 5. And I'm gonna, do I need to stop this? No, let's keep going. Let's finish first 2 pages and then we'll stop. Okay. Yeah. Okay. Perform the indicated operation and write each in standard form. So the indicated operation that I got right here is I got a polynomial minus another polynomial. Well, when you have a polynomial minus another one, you sort of treat this negative right here, or this minus, as it needs to be distributed to each term. Okay, and then we're going to add instead. All right, I'm going to distribute the negative to each term that's being subtracted, and then instead of subtracting, I'm going to add instead. Okay, so I'm just going to rewrite the first thing. 3x squared plus 10x plus 4. And now I'm going to distribute that negative, so that's going to give me minus 7. A negative times a negative is a positive, so that's plus 3x. And then a negative times a positive is going to be negative 5x squared. So now I'm going to put like terms together. I think before I had you putting shapes. I got colors, so I'm going to use colors. Matter of fact, let's keep it like that. So that's going to be 3x squared minus 5x squared. And then that's going to be plus 10x plus 3x. And then that's going to be plus 4 minus 7. So then I just compute each one of those out. So 3x squared minus 5x squared with a bigger number of second. So that's going to be negative 2x squared. And then I've got 10x plus 3x, that's going to be 13x. And then finally, I have plus 4 minus 7. So the bigger number second, so it's going to be negative 3. So my final answer is negative 2x squared plus 13x minus 3. Now this next one, I just got 3 binomials that I'm multiplying. But I'm going to rearrange this. Because when you're multiplying, order doesn't matter for the most part. 2 times 3 and 3 times 2 give you the same answer. So I'm going to rearrange this so hopefully y'all can see what's this. That's the difference of squares. So that's going to be x squared minus 49 times x plus 10. And then I just need to FOIL this out. So x squared times x, that's x cubed. X squared times 10 is plus 10x squared. Negative 49 times x is negative 49x, and negative 49 times 10 is negative 490. Whoa. And that's my answer. None of those terms can combine, so I just have that. Does anybody have any questions on that? I couldn't hear you, man. It can't combine just because all the terms are different. I got x cubed, x squared, x, and then no x's. Usually when we multiply two binomials, because the degrees are the same, we usually have a middle term. But when the degrees are different like this, because this has got a degree of 2, that's got a degree of 1. Or another way of saying it, because I got two different exponents when I multiply, it makes it where you can't combine. So that's that. Right. Right. So consider the polynomial p of x equals x cubed plus x squared minus 10x minus 10. Is x plus 1 of the factors of p? Well, there's a couple ways you could verify that. You could use the remainder theorem. Oops. Theorem. Oh, I forgot there's an E in there too. There. I forget how to spell that every time. I think it's theorem. Okay. Or you could use synthetic division. Or just regular division if you want, whichever one you want to do. So the remainder theorem says if I take the opposite of this and plug it in here, I should get 0. So the opposite of that is negative 1. So I'm going to take p of negative 1. So wherever there's an x, I'm going to plug a negative 1. So negative 1 cubed plus negative 1 squared minus 10 times a negative 1 minus 10. Does everybody follow with what I did? Go ahead, I'm listening. Because yep, that's the expression. It's a function. That's called function notation. So I'm plugging in, see, like p of x, that's where the x's are. Well, p of negative 1, wherever there's an x, I'll replace it with a negative 1. Yes, sir. That's what I did. Yeah, what about it? It's not so much it turns into a negative 1, but when I'm doing these methods, I make it a negative 1, yes. I'm using negative 1 for that. Okay, then maybe I don't get what you're saying. Yes. 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 No, it just wouldn't turn. No, because x plus 1 is a binomial that I'm multiplying. I'm saying, is this a factor? It's like saying 40. Is 9 a factor of 40? No, because 9 will go in there. But is 8 a factor of 40? Yes, because 8 goes into 40 5 times. So is x plus 1 a factor? So you can either divide x plus 1 into this and see if I get a remainder, see if I get some like a whole term or something with a remainder, or I can use the remainder theorem, which means I need to get 0. So negative 1 to the third power is negative 1. Negative 1 to the second power is positive 1. Negative 10 times the negative 1 is positive 10, and then minus 10. They cancel each other out, right? I got negative 11 plus 11, or 0. So the remainder theorem says that if I take this, I get my remainder. Well, if your remainder is 0, there's no remainder, and so it goes in there evenly. Synthetic division, I still take that negative 1, and then I take all my coefficients, 1, 1, negative 10, and negative 10. And I see if I get a remainder or not. So I bring this down 1. Negative 1 times 1 is negative 1. So then I get 0 right here, right? So negative 1 times 0 is 0. So I bring that down. That's just Negative 10 and 0 is negative 10. And then I take negative 1 times the negative 10. A negative times a negative is a positive. So that's positive 10. So I get 0. If that right there is 0, then yes, it's a factor. So the answer to the problem is yes. The left or the right, that's me verifying the method. So yes, you have to verify it by showing your work. But if you put yes or no, you got a 50-50 shot of getting some credit. But the big part of it is either the synthetic division, the remainder theorem. You could even do long division if you wanted to. But those are the two things that we kind of studied the easiest ways. And now we're just doing synthetic division again. So find synthetic division. Well, when I'm doing synthetic division, I take the opposite of what's here. So I got x minus 5. X will have to be positive 5. So I'm going to divide by positive 5. And then I take the coefficients. Coefficients is what's the constant term times your variable, or what's your number times your letter. So that's going to be 2, negative 11, positive 13, and negative 44. So synthetic division. I bring down the 2. 5 times 2 is 10. Negative 11 and positive 10 is negative 1. So then 5 times a negative 1, that's negative 5. And so then I multiply those together, right? And I get what? Positive 8? Yep. So positive 8. So 5 times 8 is positive 40. And I got negative 4. So this one has a remainder. So when you do synthetic division, you take 1 away from the degree, and that's where you start. So that's going to be 2x squared minus x plus 8. And then whatever's in the box, you just put over this thing, whatever you divide it by. Minus 4 over x minus 5. That's synthetic division. So this one had a remainder. The other one that we did not. And now I'm about to stop this thing.